This is a presentation I've given for a number of years about kind of how we run our team, how we structure our season, and how we maximize our on-field performance. My name is Tyler. Those of you who don't know me, I'm the lead technical member on the team since 2007. I'm a senior design engineer for Lakeside Custom Machinery. We make custom automated stuff predominantly for the food industry. 2010 Woody Flowers Award winner. This is kind of what I do at work. But anyways, we do automated systems. We stack a lot of boxes. It's not super exciting. But we do robotic stuff. We do kind of like FRC, except our game piece is a bag of potatoes, or a box of carrots, or whatever that might be. Frozen chicken breast.
Hey Todd.
Yep.
The laptop time is 3 minutes. 3 minutes out. Now.
Oh, so this one was supposed to start? Ah. Well, we're really done.
Not bad. There's a bunch of people coming.
Are there?
Presentation.
Oh. Okay, I'm going to stop and wait for people to get.
I think some people are coming to this.
Okay. While we're waiting,
All right.
there were some questions that got cut off in the last presentation. If you have questions about whatever, feel free to ask it while there's still time until. Come on in, come on in. Come on. There's more room around down here. Yes.
I'd say yes.
The latest one? Probably. Whatever one W Skylab supports. I genuinely don't know. Come on in, come on in. There's more chairs coming. We're all waiting for Brendan. Lots of room. Yes. Not the first day, very. Like basically, as soon as we figure out the kind of architecture of what the robot will look like, then we sit down and draw those state diagrams, and then start with Okay, we're gonna get started. Sorry for the false start earlier. Those of you who just joined, my name's Tyler. I've been building robots for a long time. Moving on. Little outline of what we're going to be talking about here today. We're going to talk about goal setting and how teams should sit down as a group and figure out what their goals are for the season and how those goals will kind of steer them down the lane or down the road. We're going to talk about our build schedule, what a typical build season looks like for us. We're going to talk about how we make decisions on this team, how we choose that is the robot that we're going to build. We're going to talk a little bit about functional design and some things that teams can be doing to build more functional robots, and just some general tips and tricks. So, goal setting. I'm a big fan of goal setting, and I think that teams should basically set goals for everything. So we start very big, and we talk about the goals that are the furthest away at the start. So we want to have goals for the whole season, but we also have goals for an individual event. or things that we want to accomplish in an individual week of build season, and things that we want to accomplish on an individual day of build season. So in our team Discord, before we come in for a day, I'll usually jot down a bunch of notes that we got to get the new hanger plates cut, and we got to get these shafts made, and all of these parts need to make it through fabrication, and programmers should work on XYZ, and we need sponsor decals made, and these are the things we want to get done for the day. And then at like 9:15, when we're like frantically cleaning up, trying to get out the door, we'll flip through that list and go check, check, check. We can get this done. Okay, this is for next day. So we want to be setting goals for, well, pretty much everything. So we start big and we work our way down. So, common examples of goals. I want to get picked for the elimination rounds. This is a great goal that any team can achieve. We want to get picked and we want to be playing Saturday afternoon at our district. Another goal might be to win my district or to win an award. Maybe your team has a lot of community outreach and you want to win impact, you want to win engineering inspiration or whatever that might be. Maybe your goal is you want to qualify for the championship and go to Houston. Or maybe you want to win the championship. But these are all goals that teams should sit down and figure out, what do you want to accomplish this season? So if we really look at kind of the word origins of it, it's the act of selecting a target or objective we wish to achieve. A better way to word it is, what does success look like for me? At the end of the day, what will you be happy with if you have accomplished? So that's what success looks like to me. This was 2019 test. So, goal set. Goals should be 5 things. They should be SMART, and SMART is an acronym for specific. We want to make sure that our goal is a specific target. We want to make sure that it's measurable. So if your goal is, I want to be good this year, how do you measure good? Is it, I want to be top 100 EPA in the world, or your goal should be something that you can accurately measure. If it's, I got these parts cut today, that's easy to measure. But something generic, like I want to be good, well, how do you want to be good? It should be attainable. We should be picking goals that are within your reach. The goal is not going to be to have a completely functional robot in 3 days, unless you're a robot in 3 days, but it's not going to be good anyway. So your goals should be attainable. They should be relevant. There's no sense setting a goal that's not relevant to your efforts. And time-based. We want to have a specific deadline for our goals. So if it's, I want to get these parts cut by Friday so that we can start assembly on Saturday. That's specific, measurable, it's all those things. So, some better examples of goals. I want a completely functional drivetrain by the week 2 of builds. That's specific, completely functional drivetrain. It's measurable, it drives around. It's attainable. Everyone should be able to have a drivetrain running in 2 weeks. It's relevant. You need to drive to score points and build a robot, so it's relevant. And it's time-based, by week 2 of builds. Or I want to rank in the top 8 in qualifying of my district. So maybe that's a goal for, I'm going to the Newmarket district, I want to be in Alliance County. Or I want to score 2 notes consistently in autonomous mode of their first class. Or win the entrepreneurship award at my district. These are all just examples of SMART goals. Or win the championship. So, some real questions. Are you willing to do what it takes to achieve your goals? Lofty goals often require sacrifice. And a lot of teams will end up having very lofty goals that require more than what they're really willing to put in. And do we even know what that is? Like I'll come back to the goal of winning the championship. There's a massive amount of effort that goes into taking that on as a season goal, if that's how you want to measure success. So unless you've been competing at a very, very high level for a number of years and you know exactly what it takes to do that, setting that as a goal is not a great measure of success. And is the whole team on board? One thing that I often see teams struggling with is they'll have a group of students or a group of alumni who are really gung-ho about some competitive goal, but they don't have buy-in from the whole team administration, the school, whoever provides your build space, and then you end up fighting this uphill battle where kind of your own team is not backing you in pursuit of your goals. So in cases like that, maybe you need to step back a little bit and reevaluate what your goals are and make sure that they really are realistic for what your resources and what your community is. So these goals kind of become the rudder of your ship. And if you keep changing them, you end up sailing in circles. So your big lofty goals, you want to pick those at the start of the season. And you don't really want to be wavering from them too much. Yeah, you can't get 3/4 of the way through build season and then suddenly decide that your goal is to win the championship. You need to start, kind of from even years before to work towards them. Questions on goal setting? No questions on goal setting? Yes.
So if you're saying you should set these big lofty goals at the start, what are your time frames for setting these more specific goals? Are they as they come up, or how far in advance are you setting?
So like a season goal, we would talk about now. So if your goal was to, go and win provincials, or you want to qualify for championship, those are lofty season goals you should be talking about now. If it's something that's that you want to accomplish on a given day, then maybe you talk about it the day before or the week before. Our build schedule, which I don't go into in detail as much in this presentation, but our build schedule has specific milestones on every week that we want to accomplish. And those we talk about the week before. But generally, the bigger the goal, the more time you talk about it beforehand. And the smaller the goal, the less time you talk. But talking about them and making sure that everyone's on board and everyone's kind of head down, pushing in the same direction is important. Yes.
You worry about a goal roadmap, and in order to do that, we need to first accomplish this, and this. And a follow-on question would be, do you worry about fallback goals? If we don't achieve winning world championship, and that was our only goal, is there anything else we could take pride in and put on our list to enjoy the season?
Yes, absolutely. I talked about that winning the championship goal as something that we work towards, and my take on this has changed a lot in the last few years too, as to how I view success as I've gotten older and matured a little bit. But winning the championship as a season goal and being that the be-all, end-all of how you measure the success of your season is not a good thing to do. There are a tiny percentage of teams that will win the championship. So if that is the only measure of success for your team, chances are you're going to be disappointed. So, a better way to measure your success would be, we want to qualify for championship. We want to go there. We want to be competitive. But a be-all, end-all of win the championship measuring, that is your measure of success, not great. So setting other goals that are more realistic and more attainable are definitely good. But I don't think you should suddenly scale back your goals, mid-season, unless things really go sideways. But generally speaking, pick one, head down, let's go. But make sure that it's something that's attainable, that you're not setting yourself up for failure in the first place. More questions? Yes.
Just curious your thoughts on result-oriented goals versus process-oriented, because the result ones, a lot of times you might not have full control, right? You can't control, say, your lines partner fall apart or something like that.
Yes.
You can't. So to hinge your end goal on something out of your control is really risky. So what are your thoughts?
It definitely can be. And FRC is a sport that has a great deal of luck baked into it, intentionally baked into it. So my opinion on this has changed a lot in the last few years, and like I mentioned, making a performance goal your be all end all is not great. And maybe the goal for your team is to have 80% of your students pursue post-secondary education. That's a great culture building goal for your team, and your students will get a great benefit from it. So performance goals are good to have, but they shouldn't be the be all end all of your season. Does that answer your question? Yes.
Yeah, sort of in a similar vein to some of the previous questions asked, versus like result versus, I guess you could say, like system goals. If we say that, like, presumably like multiple teams in FRC have the goal of winning the championship, what is like the difference that separates teams, separate those goals? And if that difference relies in their systems, do setting like sort of result-oriented goals make sense then?
They still make sense to set, just don't make that your only measure of success. Because 4 teams win the championship every year. And it's extremely difficult to do that as your measure of success. So 800 teams go to Worlds. Of that 800, 256 will play on Saturday afternoon, and then 24 will play on Einstein. So in order to win the championship, well, there's a couple ways you can do it. You can build a kind of top 8 robot in the world with the intention of captaining your alliance. Or hope to get really lucky on another alliance from a lower seed, and maybe something crazy happens, or maybe you're the steal of the second round. But to try to structure your season around ending up like that it's incredibly luck driven. And I'm not trying to take away from third and fourth picks in the championship. But there's an incredible amount of luck that goes into that. So the obvious path where you have the most control over your destiny is to try to build a top 10 robot in the world, seed at the championship, choose your own alliance, and then advance to Einstein, and then hope that you don't play against Poops and Citrus in the first round. So performance goals are good. Don't make it the be all end all of your season. Not everyone is going to be a world champion on Einstein. But maybe you can pick the losers from any other. Okay. More questions on goal setting? Okay. Our build schedule. So our build schedule from kickoff until championship looks something like this. Monday, Wednesday, Friday, we meet. We have build time here at the school 2:30 to 9:30. So the students just stay here, and those first couple hours after 2:30 when they're out of school, not a whole lot gets done robot-wise. Quite often they're just working on homework or helping each other out, or generally having social time. Mentors typically show up after work, so 4:30, 5:30 till 9:30, and then Saturdays we meet 96. So 4 days, about 30 hours at this facility. And this schedule works for us. Now, behind the scenes, on the days in between there's work that happens on CAD, there's work that happens on code, there's work that happens booking hotel rooms, there's work that happens doing all of these other things that we need to do to be successful as a team that we don't need to do here. Our time here is very precious, and we make the absolute best use of it that we can when we're in this facility and we have access to the practice field and the machine shop and the wood shop and whatever else we're doing. So we do as much stuff behind the scenes so that when we are here, we can absolutely maximize our efficiency on site. Find the schedule that works for your team. So every team's got to figure this out for themselves. What works for them, what works for their mentor base, what works for their administration, and what works for their students. But ultimately, the most important thing is that it works for your mentors, because your mentors are what's going to continue your team functioning for the next few years. So quite often I see teams that have a bunch of students that are super gung-ho and they want to put in 70 hours a week. And that is simply unsustainable for anyone with a professional career or a family. So don't do that. Anyways, find what works for you. This works for us, it may not work for you. There's lots of teams I know that meet 7 days a week. I think they're nuts, but they do, and it works for them. So more power to them. No more bag. So 2020, they eliminated the bag from FRC. And for those of you who are new, prior to 2020, at the end of build season, we used to have to seal up our robot in a big honking bag with a serial numbered zip tie and then write it on this cheesy form. And then your robot was sealed up in a bag and you weren't allowed to work on it until you got to your first event. Which was really, really dumb. So first got rid of it. But the bag was kind of a throwback to when FRC started. At the end of build season, you used to ship your robot. You used to build a big honking crate, put your robot in a crate, and then ship it across the country to some regional event that you were doing in Granite State or in Chicago or something, because there were only a handful of regionals. And you used to have to ship your robot in a big 4-foot crate. So they had everyone ship the robots in the same day. Well, that got so expensive that FIRST just decided that we'll just have teams seal the robots up and they can bring them themselves. And by that point, there were enough local events that you could drive to Hamilton or Niagara or Toronto and go to an event without having to book flights to New Hampshire. So the bag went away. What did that mean for us? Honestly, not much. Prior to 2020, we always built 2 robots. One that we would ship or seal in the bag, and then another one that we would keep and continue to develop and continue to practice with, and continue to do stuff to make us better. Now that we don't have to seal this one up, we still built 2. The reason we built 2 is the practice robot runs so much that by the time we're getting towards like DCMP, it's like falling apart. So we have this other machine that's basically identical that we drive the snot out of, and we see what's going to break. And we identify failure points long before they actually happen on the competition robot. And then we can adjust them ahead of time before stuff breaks. There was really no major change to how we approach build season, other than slightly relaxing some of our deadlines for when we have the design complete, when we have the first machine functional, things like that. But the last couple of years, I've definitely noticed that towards the back half of the season, when you're getting towards DCMP and you've been meeting 30 hours a week for the last 4 months, people get grumpy, people get tired, and it becomes a very long season. So no bag has a lot of pluses, definitely more pluses than drawbacks, but there are definitely some things that people need to be aware of in terms of burnout in the back half of the season. Questions on schedule? Any of that? Yes.
Do you ever have to add field meetings to snow days or just your behind schedule?
No. That's our schedule. That's it. So our schedule has like a whole week built in it for unforeseen delays. And we've never gotten more than a week behind, except for 2022. But that was just January. More questions on schedule? Yes.
When you start planning it?
Say it again.
When did you start planning it?
About a decade ago. The schedule has really evolved a long time over the years. So the schedule, I used to go into it in a lot of detail in this presentation, and then I had to cut out about a half an hour of it. But week 1 is functional design, week 2 is CAD design, week 3 is fabrication, week 4 is assembly, week 5 is automation. Week 6 is practice, and then everything else is auto and practice. And little iterations, tweaks, things along that way. Yes. Finish before. That's how we do it.
Can you do a driver training video also in this presentation? Is that we're just curious because
I don't talk about that.
you know,
Um,
I'm just curious what that looks like.
So we typically decide on the drive team at the tail end of build season, once the robot is like together and fabricated, based on the students that have contributed the most, based on the students that are most familiar with the robot, that have the most time commitment, that are the most mature, that we know are going to put in the time required to be exceptional drivers. And then we put our faith into them that they will deliver, and then we go. That's pretty much it. We don't do driver tryouts or training or anything like that. We know this kid's going to be a rock star, so we're going to pick him. We put all our eggs in that one basket, and that's pretty much it. More questions?
Do you have more like drive time than those meetings
Oh, yeah.
to practice?
So, basically, every day at lunch, every day after school, they can come into this facility and practice. So, yeah, they'll do a couple hours every day.
Using the older robots.
Using the practice robot, the one that looks like this, that's a little bit rattier.
So it's always built a little bit more in advance of the
About a week,
It's always a week ahead of it.
pretty well a week ahead. And we build the first one, we get it running, and we make sure that there's nothing glaring or major that we need to change. On this one, the shooter on the first iteration was completely different. And basically everything from here forward got pitched in the bin, and a new one went on the practice robot before this one was built. But yeah, the other one it looks the same, just a little bit rattier and dirtier and not falling apart. Questions? Yes.
So you mentioned how you try and get the CAD kind of done before the exam week.
Yes.
And so during the exam week, which is your practice, technically, is that more so your students, if they have time, will come in and have a product, or are you trying to outsource?
I'll talk about that in a bit. We do have two major outside manufacturing partners. But during exam week, kids have exams until like 10 o'clock. And then from 10 until whenever the school closes, the school's open, there's nobody here. So they just go make parts or study or do whatever they need to do. We don't say, hey, you gotta get these parts done if you have calculus tomorrow. Go do your calculus. But we always kind of make it. Yes.
And this room is it always open and sort of ready and set up? Just
More.
jump on and start practicing. So like overhead is kind of minimal. Is that like to get practice driving? You
Oh, they put it back.
You're
Yeah.
moving that out of the way and all that stuff.
We're doing this like recycle drive right now, which is why all that jump is in the back, but that's usually not here. Our trailer is usually parked in this ground. So other than that, and the stage is usually in the middle. But it's usually during the season when they're practicing, they walk in, put a battery in, and that's it. So we make it as easy as possible to practice a ridiculous amount and then they practice. Yes.
Teacher required to be here during lunch or?
He's just out in the hall. So we intentionally restrict the driver practice to students that we know are mature and are not going to be goofing around. So they can be in this room and practice, and the teachers across the hall, and that's okay. But we're not like running the mill or using power tools or whatever. Or practice. Okay, I'm going to go into decision making. This is super heady, but if you've never read it, this good book, Sun Tzu War, is actually really good. And there's a lot of really good life lessons in it. But this quote, if you know your enemy and know yourself, you need not fear the result of 100 battles. If you know yourself, but not the enemy, for every victory gained, you will also suffer defeat. And if you know neither the enemy nor yourself, you will succumb to the enemy. And that's like, So what am I really trying to get at? You need to know yourself, your team, what your team is capable of, and what your resources are. You need to know the enemy, which is not Team 1114 or whoever else. The enemy is the FRC Game Design Challenge. It is the events you're attending. It is the season as a whole. So yes, you want to know, when you talk about knowing yourself, you want to know your FRC team, your team members, your design capabilities and availability. Maybe you've got some mentor who's a mechanical designer, but he's only available every second Tuesday. Like, okay, that's a great resource, but if he's not available all the time, that's not going to be something good to plan your season. Your fabrication capabilities and availability. Maybe you've got some great sheet metal sponsor, but they're really jammed right now and they're going to be 2 weeks turnaround on your parts. So that's not good. You need to know what you're going to be capable of beforehand and design around. Controls and programming capability. If you're a team that, maybe you don't have a great controls mentor, or maybe you're struggling with software, designing some really elaborate machine that requires a lot of automation, probably not the best course of action in the first place. Driver skill. If you're making a robot that's really, really hard to drive, well, you're probably doing something wrong in the first place. But you want to make sure that you have a driver that's capable of handling. So teams need to be evaluating their abilities and resources honestly and realistically. Limits defined by manpower, budget. Budget is a big one in the kind of modern era of FRC. Experience and resources. Overestimating your abilities and resources is the single most harmful thing an FRC team can do to hurt their own field performance. There's kind of, if you were to make a graph of complexity versus performance for a given team, as your complexity rises, your performance will go up and up and up and up and up and up until you get to the point where this is too much for my team, and then it does this, and it just drops off very, very dramatically. So, and quite often the difference between not being able to score at all and being able to score really, really competitively is a few small little minute details that get missed along the way. So not overstepping those resources and abilities is really, really harmful. Build within your limits. This is a quote from Karthik's strategy presentation for the last 25 years. The team has 30 units of robot functions. I say units, just mystery units that are fabrication, design, whatever. And functions can be a maximum of 10. It's better to have 3 functions at 10 out of 10 than 5 at 6. It's definitely better to do less things better than to do more things easier. The real challenge is that most teams overestimate the resources and they actually have a lot less than what they think. And then they end up being kind of much worse off. I love 1114. I came from 1114 as a student, and I'm kind of picking on them here a little bit. The robot at Newmarket was not of the standard that they are typically used to performing at. And it was just because they overreached a little bit. And after Newmarket, they reevaluated and did a little rebuild, and they were smoking for the rest of the season. But, here's a good example of a team, even a storied team like 1114, that overstepped their capabilities a little bit and suffered. Okay, when I get to the enemy in Sun Tzu's quote, the enemy is the FRC Game Design Challenge. So that being the game rules. We played Crescendo last year. So the game rules, field dimensions, game pieces. The enemy is the events that you're attending, the team list, and the timeline, the schedule. FRC is a very compressed schedule. It is a ridiculous challenge in not enough time, and And that's just part of the game. So you need to keep that in mind as you go. So when it comes to decision making, you want to familiarize yourself with old FRC games. FRC's been around for 30 years now, and we've had a lot of bullshooting games. We've had a lot of game challenges that have been more or less recycled over the years. So this robot was arguably the most dominant robot in FRC history. If you look at how much better they were than everyone else that year, it was like, they were like 50% better than the second best team in FRC ever. And it was an utterly dominant performance because the robot was a single pivot with a roller claw and this big honking plunger thing that would huck the ball over the overpass. It was a really simple design that they executed remarkably effectively, and they just nailed the architecture. And it was an amazing robot. Read the rules. You have to know the rules. So I usually read the rules through, not as much as I used to, but I usually read the rules like 3 times through to make sure that I fully understand everything before starting any kind of conceptual design. Read the rules. Read the rules. You want to look at ways to score. You want to look at ways to prevent your opponent from scoring. This is often overlooked. Especially in kind of the modern era of FRC, is a way to prevent your opponent from scoring is just as good as scoring those points yourself. And effort versus reward. Some tasks in FRC are much harder than others, and yet don't provide the points payback for the investment. I'll talk a little bit more about this in my presentation this afternoon, but if we look at the trap last year, it was worth 5 points, and it was incredibly difficult design challenge to design your robot with. So you want to look at what is going to earn you the most points for the least amount of effort, and start with that, and then work your way up. So when we make decisions on this team, I'm a software engineer. I started off as a software engineer. We start with 2 lists, literally on these whiteboards. I don't know what this is. 2 lists, the functional and non-functional requirements. And we make a list of all the things that we want our robot to do, and all of the ways that we want our robot to do it. And the first 3 are always simple, robust, and practical. If we ever build a robot that's not that, somebody comes back. But when we talk about our functional requirements, the very first one was hang with a partner. Why was hang with a partner number 1 thing? Because it was super easy, and not doing this meant you for sure were not going to get the extra ranking point, or what's it called? Ensemble. Yes, thank you. If you could not hang with a partner, you were definitely not getting the ranking, or you were making it much, much harder for yourself to get that ranking. The next thing we want to do is acquire notes from the floor and store notes in the amp. And the amp was actually above the speaker. Why was the amp above the speaker, even though it was worth less points? Speaker's worth 2 unless it's amplified, then it's worth 5. So by scoring in the amp, you can unlock this massive potential in your speaker. In reality, you needed to be able to do all 3, but that's kind of the order that we ended up with. And then the trap was the last thing on our list, with a big question mark beside it. And then when we talk about non-functional requirements, things, the way we do this, the first 3 are always this. We want to be fast, we want to have a high torque drivetrain. These 2 are like directly contradictory. We want to be fast note pickup. We wanted to be really fast in order to be able to get the note from the intake to the shooter, because we wanted to be able to do the thing where we started in front, picked up the note directly behind us, and shot it on the fly while on the way to midline. And that was something that a lot of teams maybe missed the mark on. Because at a very high level in crescendo, the match was won at the midline in auto in the first 2 seconds of the match. Because those midline notes If you got one, they didn't. So it's a 10-point swing essentially in the match by winning those midline runs. So being very fast to the midline at a very high level in crescendo was critical. We wanted to never jam and be easy to operate. Jamming sucks. And being easy to operate. If your robot's hard to drive, you're probably doing something. So then we take those two lists and we kind of merge them, respecting what our capabilities are in terms of design, controls, fabrication. We identify any trade-offs. Sometimes doing task X means that you can't do task Y. So we want to make sure that we're choosing the right path. We decide on whatever our drive system is, and then those lists that we've now merged and say we want to do X, Y, Z. If we can do this, great. If we can't, no big deal. That kind of drives the functional design for the rest of the system. And all of this happens within like 2 or 3 days of the Any questions on that so far? Okay. When we are making decisions like that, consensus versus voting, we make decisions on this team based on consensus. We'll talk about things, we'll explain the pros and cons, but we don't vote on ideas. We don't have we don't have 2 competing designs and then have students vote for one idea. And the reason behind that is like, you got a grade 9 kid who's the first year on your team who's never built a robot before. Should his vote count for the same as a 10-year mentor? Maybe he's voting for the Kiwi Drive, whatever, because he thinks it's going to be cool, but maybe that doesn't align with what your goals are for the team for the season. So we don't vote. We build consensus. We talk through ideas until we get everybody more or less on the same. Don't do everything. Yeah. Generally speaking, doing everything in an FRC game is usually too much. The game designers try very hard to give lots of stuff for robots to do, which is typically too much for it's almost always too much for the average team to do, and even too much for the world elite cheesy proof citrus, too much for them. So generally speaking, don't do it. Questions on decision? Yes.
You still spend the entire week.
We don't finalize it. But sometimes the architecture comes together very quickly, and it's easy to get stuck on one thing and not explore other avenues. But we generally don't close the door to other archetypes until kind of the Friday of week 1. That's not to say that you can't start some design on things that won't change. Like my presentation this afternoon, I elaborate more on like sword drive, but I once stood in this room and said, if you're doing anything but a 6-wheel tank drive, you're doing something wrong. That day is long. That ship has long sailed. Nowadays, if you want to be competitive, if your drivetrain doesn't look like that, you're doing something wrong. So you can start on drivetrain pretty much right away, and then the stuff you build on top of it, that can still change a little bit. But generally, by about the end of week 1, we want to be. This is the architecture we're going to build. We need to design all of this stuff. So we don't necessarily lock it in if we decide on something better earlier, but we don't close the door to it. And we don't not start other stuff because we want to explore other. Yes.
Do you have a specific team where you have to kick off and become that Monday with presentations on the sort of strategic or design team to start the consensus going? We have a strategy and design team that kind of leads that on that first Monday after kickoff. Is that something you do as a team?
No, we generally have the whole team in here and we just throw out a bunch of ideas. We don't have,
Presentations, no one's.
no, we,
Everyone's read the manual and let's talk about it.
yeah, we read the manual, we review the rules with everyone, make sure everyone understands. And then once we get into, like scoring and stuff, we don't really start about architectures until kind of later Wednesday, unless there's something that's like glaringly obvious. But we don't have a small group. It's literally everyone can come in, everyone throws out ideas, everyone can do. More questions? Yes.
So your architect was this year. Do you think there's any reason process that, or it's just sort of
I was less involved. I don't know if they've had. Yeah, no, not really. Yeah, we didn't structure anything hugely different other than me being a lot more sleep deprived. More questions? Functional design. This is super fun. Robots should be simple. Robots should be really simple. Everyone builds too complex robots. Simple robots have fewer parts. It takes less time to design them. It takes less time to build them. It takes less time to program them. I know it's easy to say build a simple robot, and it's really hard to come up with an architecture that is simple, that accomplishes all of your goals. But yeah, try to build simple robots. Avoid doing everything. Talked about this a lot. We examine kind of different robot architectures. The first whiteboard sketch of this thing, this was actually an elevator. It wasn't until we laid it out in CAD that we realized that if we just made the pivot a little bit higher and moved it a little bit forward, we could get, like, what drove the architecture of this thing was really this lining up with the amp. That's what drove the whole high pivot architecture. I shouldn't say that. What really drove this architecture was not doing the trunk. Because when we ruled that out, everything got way easier. So having this line up with the amp chute meant that, like, our shooting range is basically about there. This doesn't really move very much. But yeah, we looked at a bunch of different architectures. We looked at, like, having a little snowblower thingy on the end of this thing so that we could divert the note up and into the amp that way, or doing some kind of goofy stuff like bringing the note in and the back. But generally speaking, like, we found a fairly simple architecture and then didn't really deviate too much from it. So we don't identify trade-offs of each. And the trap or no trap debate got quite heated. Because if you design your robot, you say, I'm definitely not going to trap. And then that turns out to be what earns you the #1 seed at the championship, and you not doing that has now precluded you from, pursuing that big goal, then you're kind of shooting yourself in the foot. So identifying those trade-offs and choosing the right course there is really important. How to do that requires a little bit of luck, a lot of experience, and a lot of foresight to just know how the game will play out. Yes, question at the back.
After the rest of the part of the base, how do you go to the stage?
Oh yeah, that too.
That's going to us.
Yeah, you can go onto the stage this year. You were in the wrong option. There's a question over here. Yes.
So you guys say, like, you have the robot architecture ideally done by Friday of the week, right? So, like, for example, with the craft this year,
Yep.
it was easy to identify all the hardest things to do. So when do you guys make that consensus of we aren't going to do this part of the game?
That was about Wednesday or Thursday. For me, it was like Saturday at 6 o'clock, but for the consensus, it was much later. Questions, more questions? Yes.
Have you ever identified other teams archetypes in that time too, or you only ever worried about yourself?
Specific teams,
Yeah.
or just, we think that someone would build a robot that looks like this.
Following the Good Alliance and everything.
Oh, yeah, we read all those blogs. And those are all great resources for, especially like ways to structure functionality or ways to structure a specific mechanism or how to pick up a node or how to shoot a node. Like lots of people went down the road of the like side-by-side flywheel early on, which works fine when you're like parked right up against the stage, but at any kind of range, it doesn't work. So I don't remember who the first team that kind of showed off the double top and bottom shooter. It might have been 340, or it was one of the Open Alliance teams, which is what served as the inspiration for this thing. But we definitely look at all those resources at the same time. But we're not thinking about what robot are the Hoof's going to build or what robot. We're not on a specific team. We're focused on just what we're going to build. We might maybe identify other archetypes of this is what a defense robot is going to look like, and this is what we're going to play through. But yeah, we're not thinking about other specific teams, so to speak. So a brief aside on our team's resources. So in this facility, we have CNC vertical mill. The machine shop is down the hall that way on the left. We have a CNC vertical mill, 2 manual vertical milling machines, 6 lathes, horizontal and vertical bandsaw. There's a terribly ancient box and pan brake in the other side of that wall. 2 carpentry shops, and a couple of 3D printers. So that's what we have in terms of in-house manufacturing. In terms of our outside fabrication, we're really lucky to have 2 outside fabrication partners. One of them is Westbrook Systems. And they have tube laser, which is super cool. Basically, you stick like a 24-foot length of tubing in it, and then it's got a laser and a chuck, and it'll feed the whole length of tubing through it, and it'll cut out complex parts like complete. So a part like that, it'll machine or cut all 4 faces of the tube in a single setup, and it just kind of pops out and done. Usually there's a big pile of random tubes here when I pass around. Grab me some parts and pass them around. So, Westbrook's about 50 minutes. They actually make greenhouses, like the stuff for greenhouses. So, yeah, this is hugely beneficial for us. So yeah, a part like this that's got like stuff on all 4 faces, it'll cut out in a single setup. And a part like this would take like 3-4 minutes. Which if you were to machine this traditionally on like a router or a mill, you'd be like 4 setups, flipping it, cleaning the machine off, flipping it, changing the tool, whatever else. So this is for us a huge plus. And because our schedule is so rigid, we can say that I can tell them drawings are coming on this day, material will be dropped off the day before, leave me 3 hours in your production window to cut our stuff. And then drawings go out Sunday night, and then they'll cut them on Monday or Tuesday, and then by Wednesday we have them. And in like 3 days turnaround, we have all the tubing for 4 robots. We don't build 4 robots, we just cut 4 robots with tubing. Because the setup time is like so much that it's worthwhile to just cut a bunch of stuff, and then we have extras, so that when we bend our frame in half, we can fire another one. Yeah. So Westbrook is super cool. The other outside sponsor we have is Barlow Manufacturing. They're here at Stony Creek. The company's owned by an alumni's parents, and they've been supporting us for a number of years now. They've got 6,000 watt sheet laser. So we've got 4x8s and 5x10s of aluminum sheet stuck back there. we'll take those over, send them drawings. And again, we tell them drawings are coming on Monday, he leaves a little window in production for us, and then our stuff is usually turned around in a couple of days. This stuff has to get bent after it gets cut, or at least some of it gets bent after it gets cut. So they also have CNC brake presses that can form components into complex shapes like the one that Balrog is holding in the back. That's actually the front cross member for this year's robot. So that's what took the brunt of a lot of injuries this season, and that's also why it's. So sheet metal is super cool. If you have a sponsor that can do it for you, great. But you need to have very clear communication and expectations of when you send them stuff, you need it back within time and fashion. If you have a sheet metal sponsor that says, yeah, I can cut your stuff, and then they're busy and 3 weeks goes by and you don't have parts, you would have been much better off just not designing a round sheet. Another note on kind of functional design: buy everything you can, make only what you can when you're taking it. So one of the biggest constraints and resources that all teams have in FRC, and everybody gets the same amount of it, is time. And no one has enough. So if you can buy a gearbox off the shelf that does what you need it to do versus making something custom, chances are you should just buy the gearbox. Off-the-shelf swerve drives now are phenomenally good. The days of people making their own swerve drives are long ago. Unless your goal is to make a swerve drive, and that's what your goal is for the season, then yeah, go nuts, build your own swerve drive. But if you're trying to be competitive on the field, you should just be buying SDS or Drev or West Coast or Thrifty Bot or whoever's modules and using them. Order parts early. There is a finite number of suppliers that service the FRC ecosystem, and stuff sells out. So it pays to figure out what you need and get it on order, especially if it's something niche like pneumatic wheels or I don't know, elevator blocks, slider blocks. Something that's unique to a specific game, get those on order early. CAD everything, or not. Remember your resources. For us, we're a team that has a lot of CAD horsepower, so we design everything on the robot before we do. That works for us. It may not work for you, and that's okay. Teams should be evaluating what the resources are. If you have lots of students and mentors who are really, really strong with CAD, yeah, go nuts, design your whole robot. If you're not, maybe you want to reserve the design energy for your scoring mechanism or your end effector or your gripper and not worry about CADing the whole drivetrain. So play to your resources, do what makes sense for you, be smart. Look to the past for inspiration. I mentioned this before. FRC has recycled a lot of game elements, a lot over the years. And this slide shows the 2012, 2020, and 2022 robots. And they look very, very similar. They all picked up balls off the ground. They all shot them into They all had the same shooter wheels. They all had pneumatic wheels. Oh no, 2022. But anyways, they all had the same shooter wheels. The technology has advanced a lot. The robot design really hasn't changed all that much. We just have better, faster motors that are easier to control. Questions on this? Yes.
Just a real quick one. Had the products logo up there. Do you have any tricks for importing from them without crazy duty? Every time I have, it's come with 100%.
It sucks. Yeah, it sucks.
Okay, good to know. Good to know.
Quite often what we do is an alumni of ours has a mailbox in Buffalo, and we'll ship stuff there. Yeah. Questions?
Does the school board like limit any of your spending for like outside of country?
No. Occasionally, but not intentionally, more because they're incompetent, less because they want. Yeah.
Does your design team plan out electrical layout and your sensors, or do you work with your other sub-teams to design?
Yeah, the sensor layout's all done in Canada. The electronics are all laid out ahead of time. Once we get the design mature enough to the point that we're just jamming electronics in the base where we see fit, then we pull in controls guys, controls mentors, and wiring mentors to say, hey, have we left enough room for cabling in here? And if I run a bunch of cables through this tube, is that going to be okay? And is a 3/4 inch flex conduit enough for all the cables that have to go up to the shooter? Is that enough? Then we pull them in for those discussions. And then, that happens a day or two before the big design release. And it's really just take the whole thing, take all the drawings for that. Barlow gets these ones, Westbrook gets these ones, our shop gets these ones, my dad gets these ones, and then go. And then a week later, we have like this room full of parts, and then we build this whole thing.
Your things are placed. Is that like done prior or is it done like?
That's done in CAD before it's fabricated. But if it's something that we're not sure exactly where this thing's gonna go, we'll design in multiple options. Like, you see a little series of hole pattern right here? It's for that photo eye so that we can mount it in a couple different places depending on where it needs to go. The intake, you can't see it. There's a sensor on the intake that detects the note coming in. We should have put a series of holes. We just recut the plates. We recut those intake plates. More questions? No questions? No. General tips. Finish early and iterate. This photo was taken January 22nd, 2023. So that's the Friday of week 3. That photo was taken in this room on a table right there. And that robot really didn't change a whole lot from what pictured there. That was the Friday of week 3. And that's pretty common for our schedule. That's actually tracking like 2 days ahead. Am I out of time?
Not just a robot presentation. People might have another one.
I'm almost done. Don't neglect the programmers. They do a bunch of time programming. We'll talk about this. Do less better. And that's really what I want to summarize this with. Don't do too much. Everybody does too much. They would be better off if they didn't. I'm not saying you weren't good, but in general, most teams by doing less will be. You guys were awesome last year. Because you did less better. Thanks to our sponsors. Final questions. If you have to run, by all means. Thank you very much. Yes.
But I'm interested because trying to coordinate the first robot being done by end of January. Do you also do that, or how do you adapt to exams? Do you find that basically fills a week and a half, maybe sometimes 2 weeks of film season? Do you have, what accommodations do you do for exams?
What accommodations do we do for exams?
Like, what do we do?
Yeah.
We don't schedule meetings. It's just,
Yeah.
it's just if people don't feel like they need to study, because it's literally it's one exam per day. So you still have it the whole day after that. So you can
Most of our exams shouldn't take more than an hour and a half. If it is, you're doing something wrong. So usually they end at like 10:30 or Mr. Wardell wrote it. So yeah, usually end at 10:30 and you have till 9:30. Doesn't mean you got to be working for like 11 hours straight. Like what are you even gonna do for 11 hours straight, right? So we split it up. We like if you have to study, go study. If you want to come back and like make parts, make parts. If you want to like cool down, it's really open when it comes to exams. But teachers always emphasize that studies come first. But like this place is also a good cool down from studying, so it's nice.
they can answer.
Yeah, no, it's good.
Okay, thank you all. There's a robot.
Why are you three here?